Hi, this is Miles Jaffe recording the code demo for the take home of Midterm 2 for CS 262 with Corey Montella. Spring. Is it spring? Yes, it's spring. Spring 26. Um, so I'll start with the grammar design. This was the part that I did first if you look at the commit history. So, pretty essential, pretty low level is the actual characters that make up the edges of the table. The simplest variant of which I will go through as an example. The very simple table, this table, uses the pipe, which is ASCII character number 124, I believe. More complicated tables might use these curly things, which there are four of. These T and inverse T separators, and the start and end of these horizontal lines, which are also handled. Handled as well as bold and double line variants, which I decided to make into more of just alternate variants of the character that also parse to the same thing than things that are fundamentally parsed differently by the parser. They do show up differently in the lexeme of the results of the lexer. There's also the cross separator. So the way each table works, and again I'll start with the simple pipe table as an example, is that the every table is parsed as this overarching table item, which can be any of these different types of table. The stripped down table is just one or more stripped down rows, which is some amount of table items separated by pipes. The table items are one or more alphanumeric characters surrounded by white space. And I decided to make it very general, just any alphanumeric character, because I thought that it was not particularly specified in the documentation, like what goes in these tables. More complex tables require us to have a horizontal line every other line, or surround the whole thing with the tabletop and table bottom attributes, which themselves are some number of table bars and top or bottom separators surrounded by the four curved corner things. Although I made it so theoretically they can be sharp corners as well. These horizontal lines, we'll talk about this more in the parser. I had to compromise a lot on their design. As you can see, it enables a lot of pretty bad formattings, but I decided that was an acceptable loss. Right now I just have them as a start line, some amount of white space or a horizontal bar, and some amount of separators or a horizontal column to endings. And it doesn't actively check for the end of a line because of situations like this in this particular example where we have the end of a line that's not really the end of a line, the only end of a line that we consider valid is the new line. That's pretty much all to do with the grammar. In the lexer, I have this beautiful match statement, which I thought of the business logic for, the basic idea of having a match statement with arms that look like this, filled out with Gemini because I didn't want to manually find and type in all the UTF-8 3-character encodings, but they are mostly in here. That is the only change I made to the lexer, as well as adding all these new token types that come out of that match statement. Pipe is handled separately. Pipe is handled in here because it's a real ASCII character. And spaces and new lines are now considered differently because we grammatically care about new lines in the table where we didn't really in homework 2. So let's get into the parser. First major change is that I made a macro for the single token parsers instead of messing around too much with copying and pasting that one code block. This was also with AI's help. So as you can see, just all these, table parts get their own thing. And I did not make any major changes to the homework 2 code, other than just minor tweaks so that it would continue to work with all this new stuff. So again, let's go bottom up. A table item is some number of alphanumeric characters surrounded by spaces. This will never actually hit, so I made it space 0 because we strip out all the spaces in the lexer, as you can see. But it's grammatically correct. So the stripped down row with pipes is a many one statement preceded by a pipe. So it's pipe and then table, pipe, table, pipe. This could have theoretically been a, where is it? One of these, the separated list 1. But I kept running into the classic separated list 1 issue involving it seeing the final delimiter character as part of the separated list, and the delimited statement, or that is this terminated statement, getting confused when it immediately saw a new line. So now it's just a terminated preceded type thing, which I guess I could turn into a delimited statement. I'll probably do that after I record. A table row is much the same thing. It's a table side, and then repeating one or more table item, table side, table item, table side. A table side being a vertical bar. The tabletop is the thing with these top left characters and 0 or more of these T separators. And same with the bottom, which is the exact same code. except a new line is optional after the bottom because we might or might not actually want it. For the horizontal lines, these horizontal lines, this was by far the hardest part of the creation of this, dealing with example 7. I originally had much more complex logic, looking for an alternation between horizontal column to a separator. Now I've just changed it to some number of horizontal lines or spaces and some number of separators. It doesn't really matter because the horizontal line doesn't have semantic meaning. It might if we were parsing the column data as well, if we wanted both rows and columns, but the point of this parser is just to have rows. Columns would be, I would say, a stretch goal. Something to do in the interpreter rather than just the parser. And as in the grammar, this is just an implementation of the grammar. The table checks for one of these. And let's just quickly get over here. I'll come back to this in a minute. But the structure of a table is a table item with table row children, and the table row children have table item children. I thought of a lot of possible expansions of this, one of which was a function to split the token list by each new line and just check that every line was the same length, because I still have the line and column data left in my tokens from homework 1. So just verifying that every new line is at the same column, or at least that every line ends on the same column, to protect against the cases where there might be spaces or random garbage before the new line after the table. And that, if I decided to make that, that would go at the start of each one of these, not this, well, maybe this, but each table parser combinator, just to make sure that all the lines were the same length. Checking, as I said before, checking individual column sizes, I decided to be out of scope. So let's run the tests. All these tests pass. So let's take a look through them. This is all functions. So there are 20 tests relating to the tables. The first 7 are just the 7 representations that were given to us. Instead of having different types of tables, the names of which would have to be arbitrarily chosen, I decided to make all these just evaluate to a table. These all come out to the exact same thing, all these first 3 tests, even though they're formatted differently. There is an internal tabletop object and table horizontal separator line in the parser, but it does not see the outside world. So these are all the same. This correctly alternates between lines of data and the horizontal separators. You can have a header, which is just a row with only one item. Rows can be different lengths. And the most difficult feature out of the default examples given Can also have a vertical column with no separators. I wasn't sure whether that should be considered differently, but I decided to put everything on a row as part of a row. So my three custom tests here, we're testing a horizontal line alone, to show that the horizontal line item existed. It was just deliberately being removed before it saw the outside world. A table without tabletop and table bottom, but with horizontal separators could exist, and testing that the bold characters could exist. Again, obviously, this evaluates to the same thing as this, but theoretically, if I really wanted to, I could have introduced new token types, and had a way to evaluate a box for having bold characters above it and to the sides. So the Lexer stuff, all these tests are guaranteed to pass if the parser tests pass, because the parser tests involves lexing the source. But I thought it was useful to be able to see all these tokens. You see VS Code's slowing down with the length of these lines. But yes, pipes show up, table side stuff shows up. You can see the tabletop left character, and at the end of the last line, there is a table bottom right character, etc., etc. You see the start line, cross separator, and so on and so forth. And these do lex to the same characters. If I wanted to make the bold characters unique, I could change this code, this particular code, to say, or to have a alternate version up here that changes the lexeme to be all three characters in this vector, instead of just the first character of it. So in terms of rejecting the malformed tables, let's show a few examples. So without one of these tabletop items, test 5 will fail, as well as without the end, oh never mind, without the end of a line of data, that fails, and with nothing in a box, that fails. And it also applies for the Lexer tests. You see. Although with the Lexer tests, it's a little more obvious because it's just like an actual character just straight up plainly not being there, instead of the more subtle changes that happen here. The biggest challenge here was dealing with this stuff, the very many options that were available when considering what a horizontal separator line would look like. And I went for a very permissive solution that enables a lot of badly formatted lines to be read as though they were valid. I just decided it was more important to be reading data than to be rejecting this hypothetical malformed data that's not even that big of a deal. Um, Another issue was deciding what to keep out of scope. This was definitely a topic where I could have been exacting and worked for a ridiculous amount of time to add features that nobody cares about. Um, one of which being column sizes, keeping track of column sizes, which would definitely be necessary if we wanted to think about this in terms of columns. Um, like making sure the span shows up in both the ABC column and the B span 3 column. Um, but that would have been quite difficult, and it was not mentioned in the documentation. So something I maybe could have done in that direction would have been, again, because I'm keeping track of column and line data still from the Lexer. I definitely could have tracked where separators are relative to the data and used that to create columns, potentially including multiple items per column. Yeah, I think that's pretty much it. Let me just show all the tests passing again. Backwards functionality is still perfectly fine for the homework 2 Asa Lang material. Thank you for your time.